Any questions about anything before we get started with this exciting topic? So this is essentially about the first coursework, how to read a computer science research paper, extracting the essentials. I'll give everybody a little warning. This is pretty difficult, what we're going to talk about today. It's a skill, and it's not an easy skill. It's kind of difficult. It gets easier with practice, but I think in the beginning it's difficult. Yeah, so that's just a little warning. And on Friday, we're going to be practicing this skill in the workshop. I put some links to some supplementary tutorials on this topic on the Moodle page if you want some supplementary tutorials. So we're going to talk about how to read these complicated research papers, right? This is a research methods class, and part of that is looking at previously published research papers. And you probably have started looking at those research papers, and you thought to yourself, these are complicated. What do I do? And that's essentially what we're trying to answer today. So the second coursework, to put this in the bigger picture, the second coursework is a literature review. So in order to put together a literature review, you need to look at several research papers, right? That's the context. Why do you put together a literature review? A literature review will help you discover what problems have been solved and what problems are not yet solved. And doing original research requires you to work on an unsolved problem. By the way, your master's thesis dissertations do not require you to work on an unsolved problem. But research in general, good research in general, does require you to work on an unsolved problem. A single paper, some of you may have noticed this, a single paper can be very complicated if you've tried to read it. How many people here have tried to read some of these previously published research papers? Anybody try it yet? That's good. So if you've tried it, then you'll like this lecture more. You'll be able to follow it better, and you'll find it more interesting. Right? They can contain lots of details, like a complicated mathematical framework, maybe a complicated algorithm, or a very complicated data analysis techniques. So they're complicated, generally speaking. There are exceptions. In each one of those papers, there's a list of authors. Typically, there's a list of authors there. And they've all spent a year or 2 or 3 working on that paper. Right? It doesn't happen overnight. It can take 3 or 4 years to publish one of those papers. So imagine a team of PhDs all working on the paper for a year, 1 to 4 years, right? So it gets complicated. There's a lot of knowledge being invested by usually very experienced people in those papers, which makes them even more complicated. The other challenge is that there are many of those papers, so millions of previously published research papers. That's a challenge, right? How do you navigate the previously published papers when there are so many of them? Right? This is one of the top challenges in any field of research, is keeping up with the massive volume of literature. It's really not easy. It's difficult. This challenge is difficult for everybody. no matter how much experience you have, including myself. Like, there's no way around that challenge. Right? And this lecture is a little bit of one of the skills that we can use to navigate the complexity and the volume. Right? It's not perfect, but it's a lot better than nothing. Right? This skill was not taught anywhere. It didn't exist 20 years ago, right? It just didn't exist. There were no special techniques, 15 or 20 years ago at all, right? No strategies. So this is a strategy that can help with those challenges. So this is just an overview. Actually, we're not going to talk about related work. We're going to introduce this concept of distance and close reading, and then we're going to talk about concept versus implementation and how we use concept versus implementation to extract the essentials of a computer science research paper. So the essentials are a short description of the concept, a short description of the implementation, a short description of the related work, a short description of the data characteristics, and a short description of the evaluation. Those are the essentials of a research paper, right? And then the question is, how do we focus on those and extract them, right, in a concise and efficient way? We're going to look at some examples and then just mention this idea of breadth versus depth. By the way, if you have any questions or comments, please interrupt. I'm happy to take questions or comments. I have already got some email on this topic about people that are nervous and concerned. And I think that's good, actually. I think it's good because it means you recognize that there's a challenge in front of you that's not easy. So you're more likely to, I guess, pay attention in class when we talk about it. Also, I give these warnings not to be, some authoritative figure, but I think the warnings are helpful because imagine I didn't give any warnings and I just said, boom, here it is. It might not register in your head the importance of what just happened. And this has happened to me before. I remember when I took my first calculus class, we started to go over integration. Has anybody here ever taken calculus before? I remember the first time we were going over integration, that the teacher didn't give any warning. He just said, we're going to start integration today. And I got completely lost. I was like, I have no idea what just happened. And I would have liked it if he had said like, oh, here's a little warning. This is really difficult what we're about to talk about. So like, wake up, So I didn't get it the first time. I didn't get it. And I had to do it again. Like, take the lectures again to understand it. Okay, so not all of the details. So you have this complicated research paper. It's 10 pages long. It could be 20 pages long. Not all of the information in that paper is essential or relevant to you in your project. Right? That's the good news. So the goal is to figure out this technique of extracting exactly what you need in order to summarize a paper and in order to put together a literature review. So it's like you have these 10 pages. Where in those 10 pages is the stuff that's important that you need to take out of it? And then you just leave the rest. The rest is not that important. Right. And literature reviews are a good way to obtain an overview of a field, right? To understand what has been solved and what hasn't been solved, and who has done what previous work, right? What work has been done. And this technique that I'm going to describe is based on previous experience of reading lots of papers and writing lots of literature surveys and publishing the literature surveys, right? And supervising students. This is kind of just for fun in some ways. This is not absolutely like critical, this close versus distant reading. But there exists a notion or notions of close versus distant reading. Now, the close reading is something you're already familiar with. A close reading is you pick up a paper, you start to read it, the first sentence, until you finish the first sentence, then you move on to the second sentence, then you move on to the third sentence until you're finished. So you read a paper from start to finish, sentence by sentence, word by word. That's called close reading. Distant reading is when you replace the text with symbols that represent the content of that paper and its characteristics. Right? This is an example of distant reading. Each one of these symbols represents one research paper and some of its characteristics. Right? This represents a research paper, right? It happens to be in the field of flow visualization. This represents a paper that talks about steady state flow, or that's not important for you guys, but it represents a paper and it has a special data characteristic. And here are all of its children. So all of the children are published papers that build on that technique. They found something about that technique that's unsolved, and they've all proposed solutions to the problem, right? And then there's another one here with 1, 2, 3 more children that have all identified an unsolved problem, and then they've proposed solutions to those problems, right? So this is called distant reading. So we're not actually reading the papers at all. We're replacing the papers by symbols that represent the characteristics of the papers themselves, right? Distant reading is seeing only a visual representation of a paper, a map or a graph for a large numbers of papers, right? So this is a summary of 25 papers and how they're related to each other. That's distant reading. And what we're talking about today is in between distant and close reading. It's somewhere in between. We're not doing perfectly close reading because we're not reading the entire paper, but we're not doing distant reading either because we're still looking for text. We're doing something in between. We're looking through the text and then we're identifying, oh, this is the critical stuff right here. This is what I need to take out. So it's a kind of stepping stone in between close and distant reading. Do I have everybody's attention? So this is where the real stuff comes up, the real content that you really want to understand your best, do your best to understand. So when we read research papers, we want to make a distinction, we want to make a distinction between concept versus implementation. We want to try to make a distinction between concept versus implementation. What does that mean? What's a concept? A concept is a general notion, idea, or conception. An idea of something formed by mentally combining all of its characteristics or particulars, a construct. A directly conceived or an intuited object of thought. These are all different definitions from different dictionaries, like dictionary.com. They're hard to understand, right? In my own words, a concept is an idea. If I just say it in my own words. A concept is an idea, and it's usually an idea about how to solve something. Like, I have a problem, and now I have an idea of how to solve it. That's a concept. Right? Implementation is, how do I actually go about solving the problem and implementing it, or making it real? Taking it from an idea in my head to making it a reality in the physical world. That's implementation. Right? Implementation, if we look it up in the dictionary, the act of accomplishing some aim or executing some order, the act of implementing, providing a practical means for accomplishing something, carrying into effect. Right? That's from dictionary.com. These definitions are not that great, but that's what they say when you look them up in the dictionary, right? So a key element is to separate, when reading a research paper, to separate these two things, concept and implementation. Like, how can I look at a research paper and then read what I'm looking at and get the concept out and the implementation separately? How can I separate these two things? I want them, they're two different things, and I want to separate them, right? I'll just go over some examples, right? These are my own words. A concept is abstract, not something with mass that can be weighed on a scale. It's in your head, right? A concept is in your imagination only, basically. That's where it exists. The implementation is that idea brought into the physical or digital world, right? It's what you do to you actually realize the concept. You want to bring the concept into reality through an implementation, right? So an implementation is a concept that has been brought into reality. Right? A concept usually starts out as an idea in someone's mind. A concept is then written down on paper, perhaps as a hypothesis or a specification, and then a concept is implemented. Right? You can think of this sentence like, I have an idea, I have a concept in my head, and then the next question is, okay, you have this idea, how are you going to make it a reality? That's the implementation. Right? So concept versus implementation. Gesundheit, separating these two things is very important. It's an essential skill when reading research papers, separating these two things, concept versus implementation. Any questions so far? If you're thinking, oh, this isn't very difficult, like, I understand you, Bob, that's true. It's because it's not that difficult. What I'm explaining right now is not that difficult, actually. It's pretty straightforward. It's only when you actually apply this to research papers that it gets more difficult. So this is not difficult, what I'm saying right now. Here's just an example that has nothing to do with computer science. Yeah, it's just an example to give you the idea, right? I want, for example, I have this idea in my head. Oh, I want something that I can write with, right? Instead of just communicating verbally, which is what we did for most of human history, somebody said, oh, I want to, instead of just communicating verbally, I want to write things down, right? So writing things down, a tool to write things down, like a writing utensil, is a concept. Somebody got the idea, oh, I want to write things down. And that's an idea, it's a concept, right? And if I try to articulate it, and I would say a writing utensil is a concept. It's a tool, and if I want to try to define it in more precise words, a tool that can be used to communicate with others by symbols drawn by a person, right, rather than their mouth. That's the concept. And then the implementation is, how do you make that a reality? You construct tools, essentially, right? You construct pens, pencils, markers, whatever, rocks, right? A pencil is a type of writing utensil, or more specifically, it's the implementation of a writing utensil, right? With a pencil, graphite is used to write down on a piece of paper. So we've separated out the concept from the implementation. Everybody with me on that? It's pretty simple, right? It's nothing that complicated. Some other examples, somebody got this idea in their head, I want to fly. Right? At some point this was a concept. It still is a concept, by the way. Like flying is a concept. Oh, how do I get from A to B fast? They start with the problem, oh, let's fly. So it starts as a concept. And then what's the implementation, right? It could be a plane, right? The first planes, were air powered. There were propeller planes, right? There are jet planes. There are hang gliders. There's lots of different implementations of this concept about flying. Right, so it starts out as a concept, and then there are many different implementations of that concept. Same thing with motor vehicles, right? Somebody said, I need to go from A to B faster. How do I do that? On land, And then people started working on millions of different implementations, like horses, bikes, cars, mopeds, now it's electric scooters, millions of different implementations of the same concept, getting from A to B on land. Does that all make sense so far? So concept versus implementation, getting those two things separated is an essential skill when you're reading these research papers. And some of the other sort of side notes, let's say, there are an infinite number of implementations for any given concept. So with the writing utensil example, there are millions of different writing utensils, right? There are millions of them. Like these right here. This is 1, 2, 3, 4, 5, 6, 7, 8 different implementations of a writing utensil. They're all different, all of these, right? They're infinite number. If everybody takes out their pens and pencils in this classroom, probably every single one of them is different, right? Same with planes, automobiles, any implementation. Essentially an unlimited variety of different implementations for a given concept. So this is important. For a given concept, there are many different implementations. And that's something you want to have in the back of your mind when you're extracting the essentials of a research paper. Right? Okay, so this is it. This is the what you want to extract. So I give you a research paper and I say extract the essentials. This is it. This is what you want to extract. You want to extract, number one, the concept of the paper. What is the idea of that paper? What are they trying to achieve conceptually? What is the goal of that paper? This is also the contribution of the paper. What is that paper contributing to science? What is the new aspect that they're trying to contribute? That's called, I'm using several words for the same thing. Right? Concept in this case is synonymous with what they're trying to achieve, which is synonymous with the goal of the paper, which is synonymous with the contribution of the paper. What does that paper contribute? What advances is it making beyond the current knowledge? That's the concept of the paper. So the first essential element you're trying to extract is the concept. And anybody know where you can find the concept of a paper? If you have it in your face, if you're sitting there reading it?
Abstract.
Yes, you can find it in the abstract. Any place else? Can you find it any place else besides the abstract?
Results at the end, conclusion.
I wouldn't look there. Introduction, exactly, good. You guys are going to do well on this, I can see. So the concept is stated in the abstract and in the introduction. You might want to read both because sometimes the abstract, although it does say what the concept is, it's in such a short form, it might not be like enough. You might want to read the introduction to get a better idea, a more detailed understanding of the concept. Okay, implementation. So we've separated now. We now know we can separate the concept from the implementation. How is the concept realized? In other words, what are the authors proposing to do in order to show their concept, in order to realize it, right? How do the authors support their hypothesis? What do they do to implement their concept? And that's something, that's a skill to summarize that. But this is really big. This is really big because most papers, if you look at them, the most space and the largest number of words is taking that implementation to describe the implementation. They have a concept which is pretty easy to articulate usually, just in a few sentences, but then the rest is implementation details, like really complicated. But we don't need that actually. We just need a rough idea of how it's implemented. For example, they've developed an algorithm in software to make this process faster. That's the implementation. So you've taken a mass amount of complexity and simplified it down into just a few sentences. The related work, right, is an essential element, right? In that slide we showed on distant reading, we showed how the papers are related to each other. That's all about the related work. How are they connected to each other? Most, but not all, research papers have a related work section. And usually it's complicated too. Usually the related work is like, oh wow, lots of previous papers on this topic. Oh, it's complicated. But usually, not always, there's one previous paper that's kind of special where they really say, actually, we're building on this previous paper. All these other ones are related, but there's one special one that we're really focused on. We want to beat the performance of this one. Like we're re-implementing this solution, but we're making it double the speed. So there's usually one or two papers in the related work that really are the most closely related, let's say. And we're trying to extract those. We're trying to identify the one or two previous papers that are the most closely related. That's an essential aspect. Most research papers build heavily upon one or two previous papers. Which ones are they? So that's, you have to look at the related work section and read it to see which ones. The characteristics of the data are good to look at. So usually, not always, there's usually some data involved. Right? The data could be used for testing and evaluation purposes. Right? If you're trying to make something faster, there's a process and there's input data and there's output data. What does the data look like? What kind of data are the authors actually using? Is it spatial data? Is it abstract data? Right? Is it time-dependent data? Or is it not time-dependent, like static data? How big is the data set size that the paper is looking at? Right? Is the data structured or unstructured? There are lots of different kinds of data, so you want to identify what kind of data is it. Is it multivariate data, for example, and so on. And this is it. These are the absolute essential characteristics. And then it's a skill to extract these. But you can see, you can imagine, oh, I can extract this information without reading the entire paper from start to finish. You can extract this, actually. And as a skill, when you develop this skill, you get better and better at it, and quicker, right? You know, it might take 2 hours the first time you do it. But then the more you practice, the second time it might only take 1 hour. And then when you get to the more practice, you try to get it down to just 10 minutes, for example. Like, I can extract the essentials of a research paper in 10 or 15 minutes. That's like the kind of expert level, right? And also an expert can get the concept out in just 60 seconds, right? If you just want the concept of the paper, because why is that a good skill? It's because you're trying to decide, does this paper fit inside my literature review or not? And to answer that question, it's a conceptual question. So if you can extract the concept out really quickly, you can decide, oh, does it belong in my literature review or not? Very quickly. So that's the template, right? Essential information extraction template. I love templates, right? I made a note about that already. Bob's Minutes of Meeting Protocol is a template. This is another template. Templates are structured, they're systematic, they're repeatable, right? They help with organizing things. So we're going to also just mention analysis techniques and evaluation techniques, right? Maybe other useful information like a sample image from the paper if we want to summarize it, the URL of the PDF, and a DOI, the digital object identifier. So if we're just following a template, this is a good one to follow. Any questions so far? So here's where it gets difficult, like when you actually pick up a paper and you try to extract this information. This is just an example, right? The problem with this example is you didn't get to see me do it. Like I pick up a paper, I extract the essentials, but you didn't get to watch me do this. So I'm just showing you the end result, but this is what it can look like. Right, this is the title of the paper, Fast and Resolution Independent Line Integral Convolution. Right, but the title is complicated, isn't it? It's like, what? What are you talking about? What's the concept? So the concept is they just make a faster version of a previous algorithm. That's the concept. They take an algorithm called LIC, and they make it faster, a lot faster, like 5 times faster. That's the concept. And you can see that concept in the abstract of the paper and the introduction. Right? But most of the paper talks about the implementation. You know, if the paper's 10 pages long, probably 6 pages are just about the implementation. So I've summarized the implementation in one sentence, or 2 sentences. They achieve this by reducing the number of redundant streamline computations, and they develop an improved streamline integrator with adaptive step size control. By the way, does anybody know where you might look inside of a research paper to get this implementation? So imagine you have 10 pages and 6 pages are dedicated just for the implementation. Anybody have any ideas where you might look to get a summary or the essentials of the implementation?
Methodology.
In the method section, that's right, there'll be a method section. If it's a well-written paper, not all papers are well-written, by the way, and clearly written, and clearly organized. But if it's a good one, there will be a method section, and at the beginning of that section will be a summary of the method, a 1-paragraph summary of the implementation. So look for that paragraph, if it's a good one. Not all papers are going to have a good structure with a nice introduction and overview of their method or their implementation, but most of them do. Most of them will have a nice little summary at the beginning of their method section or their implementation section. And there you can extract the short summary. Name?
Now,
Yeah.
about the results section, they will discuss what they say, results section.
That's good. You're going to do really well. I already said that, didn't I? You asked a good question last week, too. And you're going to do really well. So he asked about the results section. I haven't talked about that yet, but I'm going to. I just want to go sort of one step at a time. And then the related work section is kind of big. It's like a page or whatever. But there's one paper that they're really focusing on. You know, there are a bunch of related papers, like 10, 20 related papers. But if you look at the related work section, you'll find out, there's really one paper that they've decided we are going to double the processing speed of this one previous paper. So it builds upon the original LIC algorithm. And then there are some data characteristics of there, right? This is 2D data we're talking about. It's static data. In other words, it doesn't change over time. It's uniform resolution. It's on a grid. And it's vector data. This is a sample image from the paper. I just took a sample image, put it in there to get a visual representation of that paper, right? You don't want just text. You want some image, something visual to associate with the paper. And this image is special, right? It looks different. You know, it looks like, what's that? That looks interesting, right? Okay, these are the other candidate essentials, what you asked. Some other characteristics that can be used and summarized are analysis techniques. What basic analysis techniques are used? Did they do a statistical analysis, for example, a visual analysis, or some other software tools for analysis? And then evaluation techniques. This is about the results. This is essential, the evaluation technique. How did the authors evaluate their results and show the reader that what they're saying is true? Like, they're saying, we have this idea to double the speed of this algorithm. Now we're going to write some software to show that it's true, and we're going to do a performance analysis to show you that it's true. So that's the results. What are they doing to show that in their evaluation, to show that their results are true, or trying to demonstrate their results? They could be measuring performance time. That's just one strategy, right? They could be doing some sort of human-computer interaction experiment to demonstrate that their results are true. They could be focusing on a case study. So that means they have a special problem that they're trying to solve. And they apply that solution to that special problem that they're trying to solve. Those are just some ideas. Like the research paper could say as a concept, we want to build some software that has a much lower error rate when people try to use it than the previous software. Like we've noticed that people have lots of trouble using this software, so we're going to design a new one that's much easier to use. And in order to evaluate that, you need to test it out on people. Right? So that could be the evaluation strategy, to run a user study, to test it out with people. Right? So that's the other kind of essential information, is really the evaluation is essential. How is it evaluated, that software or that technique that they're proposing? Does everybody find this exciting? Everybody is blown away, like, I can't believe we're learning this. This is so exciting. For me, I think it's really interesting because I remember when I was a master's student and I had friends that were doing research, and I had some friends doing their PhD. And I had one friend who printed out the papers that were related to his PhD. He printed them out and he put them in a stack like this tall. Has anybody ever seen a stack of papers somewhere? Like research papers, or in somebody's office somewhere, or just anywhere? Has anybody ever seen that before? I remember seeing that stack of papers and just thinking, how is it possible to process that information? That just seems impossible. And in my mind, I was like, that's impossible. I don't believe that anybody can process this stack of research papers and make sense of it. I was like, I don't believe it. And it was true. At that time, it was true, what I was saying, because this method didn't exist at that time. But now we have a strategy. We can go through each paper, pick out the concepts, and then start to put them in different piles, depending on the related concepts, right? Okay, here's another example. The title is called P-Light, a study of parallel coordinate plot literacy. So this paper contributes, look, it's using the word contribute, right? Because a paper is contributing something to science, some sort of knowledge. A pedagogical software tool and a literacy test for parallel coordinates plots. This is what a parallel coordinates plot is. So what they're doing is introducing both a software tool and a test for parallel coordinate plot literacy. In other words, to study how people read and interpret these graphs. That's a parallel coordinates plot, right? Implementation, the software uses linked views of scatter plots and parallel coordinates plots, and the test is done using an online tool called Qualtrics, and it's used to conduct a user study. That's the implementation. So I've summarized. The implementation in this paper is like 10 pages, but I've summarized it in 2 sentences. By the way, this is where everyone gets lost. This is where, when you pick up a research paper, this is where everybody gets lost. And they think, oh my gosh, there's so much complexity here. And it's true. It's because there is a lot of complexity there. But you don't need to know about all the complexity of previous implementations. You just don't need it. It's not essential. It's not essential. So they have a related work section. right? It's got like 20 papers in it, but there is one previous paper that's quite special, and they really build on that previous paper, right? And so we've identified that. The data characteristics, so this is not spatial data, it's abstract data, this data. It's steady, in other words, it's not time dependent. The resolution is not applicable in this case. It's something like 4,000 records. There's no grid structure, but it is multivariate data, so it has several variables. Right? That's not too difficult to understand. So in order to implement or to realize their results, they conduct a human-computer interaction experiment. So they build their software, and then they need real people to come and test it out, right? And they report the results of that test, right? So this is the evaluation of user performance. They're studying the people that use the software, and then they measure their response times, like how long it takes them to complete a task, and the error rates, how often they make errors. But I don't go into that detail. I just say, oh, there's an evaluation of user performance. That's all I have to say. That's the essential information. Right, so I've taken a complicated paper, it's probably 10 or 20 pages, and I've condensed it down to one slide with the essentials. Right, that's a skill that I've developed over several years, and that's the skill that you guys are trying to learn in this module. Right. Okay, we'll go through one more example and just that's it, and then we'll wrap it up. This is the paper called Marching Cubes, a high-resolution 3D surface construction algorithm. Right. The title again is very complicated, and then the question is, oh wow, that's a complicated title. Like, what's going on there? And you try to extract the concept. So it describes a novel algorithm for the construction of large isosurfaces. You could just leave out the iso part and just say large surfaces. Right? Isosurfaces are a special kind of surface. There's the implementation, but this looks complicated, right? But there's a summary. There's an overview summary in the paper, and I just look at the overview summary of the steps, and I can summarize those steps without too much difficulty. Right, there's six steps there, and I just summarize those 6 steps. Right. Most of the paper is about the implementation, but I don't need to know all the details about the implementation. I don't need it. It's not essential. They have a related work section with like 20 papers in it, but if I look more carefully, I find out that there are 2 previous papers that this really builds on. And then I look at the data characteristics. This is 3D data, right? This is a surface extracted from 3D data. It's static data. It has a resolution of 128 cubed or 256 cubed. It's on a uniform grid, and it's scalar data. They build a piece of software to demonstrate that their concept works. And their evaluation is based on data set size, memory, and performance time. So when they run their algorithm, they're looking at how fast it runs, comparing it to previous work, how much memory it takes. So they're actually looking at the memory requirements too, not just time, but space and time. So again, that's a paper, 10 pages, summarized, the essentials summarized on one slide. Okay, just one little comment. Right now we're focusing on breadth. So dissertations usually start with breadth. In other words, You want to look at lots of different papers and get a brief idea about what's happening in those papers. That's called breadth. And then once you know what you want to do, you can, if you want, go into more depth. Right? You can pick out one research paper if you want to, that you think, oh, I really like this one, I'm going to improve this one. That's called depth. We're not talking about depth right now. We're at the very beginning stages of our projects, the beginning stages of our research. We're focusing on breadth. So these are the terms used generally. Okay, any questions about that? So I hope it made sense. This is a very special skill that a lot of researchers have. It can be developed, and it can help you navigate that jungle of complicated previously published papers. And we're going to do this on Friday, by the way. We're actually going to do this in the workshop on Friday. Question?
So I'm wondering, when we focus on depth, do we think it critically, like to check if the evaluation method is or not? Can I take some time first? Is that what we need to do in this stage?
That's not something we worry about now. You're concerned about breadth right now. You're just trying to figure out what to do, right? Only after you figured out what you think, you're like, okay, I really want to do this, then you can think about depth. But don't kill yourself trying to understand the implementation of any paper. Like, don't bother. And I could have a separate lecture just on that, actually. But like, for example, the page and the space limits of a paper can prevent all the details from being published, right? You might see a paper and say, I want to reproduce this, but maybe there's some things that they left out that even prevent you from reproducing it. You can actually contact the authors of the paper if you have questions. You say, oh, I don't understand what you did here. You can write to the authors, and usually they will reply, usually. But you don't have to worry about depth. Don't go into depth on any paper unless you've discussed it with your supervisor first, because otherwise you're just wasting your time. Your supervisor might say, okay, I want you to read this paper, but read it carefully, like in depth. Then you can go ahead and do it. But otherwise, don't. Don't do it. It's not going to be helpful for you. The most helpful thing you can do now is try to see if you can get this skill. This is a skill, and you want to try to develop it. That's the best thing you can do right now. Any other questions?
What kind of questions advantage us the author? What kind of questions? I'm a little afraid that the question is really easy.
Yep. Don't worry about that. Imagine you're a teacher. Are you going to get upset if somebody asks an easy question? No, you're not going to get upset. What kind of teacher? Who does that? Nobody cares. Like, okay, let's put it another way. If I'm an author and I published a paper and somebody asks me a question, do you think I get upset? No, I'm happy about that. I'm like, oh, somebody read my paper. That's so nice. Like, and they have a question. They're happy. Like, they're happy when they get correspondence. Because it's like, oh, somebody else in the world is alive. There's life out there. Yeah.
A good research reaction. How could we know that is a good paper? how to define it?
That's a difficult question. So how do you decide what's a good research paper? My initial reaction to that are two. One, you talk to your supervisor and say, what's your opinion about this research paper? Is it good or not? But one piece of evidence for a good paper is it has a DOI, the digital object identifier. If it has a digital object identifier, then probably it's a good paper. But you would do both of those things. You know, like when I'm supervising a student, I'll say, go and search for papers on this topic. Don't do anything. Just go and get them, put them in a folder of PDF files, and then I can tell you which ones are good and which ones are relevant and which ones are not. So we do that a lot. We say, like I say, go find these papers on this topic. They collect them in the PDFs in a folder, and then we'll go through and we'll say, okay, good one, not good. Good one, not good. You know what I mean? Yeah. Any other questions? Okay, let's, one more quick one.
And so when would you know that you read enough universally discovered
When do you switch from breadth to depth?
Yeah, how do you know that?
That's something you would talk about with your supervisor. Yeah. Okay, let's stop. And if you have more questions, I can answer them after or on Friday.